Okay, hello everyone. As Mark said, my name is David. I am Scottish, so I'm a little bit tired. I'm very excited to be here. A few facts. The national animal of Scotland. Anyone? The unicorn. So, not sure how that slipped through. So I have quite a lot of pets. I have 9 here, so I have some chinchillas. A question already? No, I've not caught a live one yet. But I have chinchillas, I have dagoos, and I have a ferret. I like esoteric programming languages, such as Pony, Rust, Elixir, things like that, and I'm a member of the Kubernetes release team. Now, I know that in California, ferrets are illegal, and that's because they're considered dangerous to the natural wildlife. Here's my ferret, looking super dangerous. It's very cute. Okay, so let's establish a baseline for what I'm going to talk about today. What I want to cover is just a few use cases for Telegraf that make it very, very, makes it useful and allows you to adopt a few different patterns, especially around adopting containers in Kubernetes, and we'll talk about resiliency as well. Now, this has been covered a few times now, but Telegraf does have a lot of plugins, so there's a lot of things here that I could go through, but obviously I only have 35 minutes. So I'm going to be a little bit more specific about what I talk about. But Telegraf is a very fast-moving project, right? In May, there's a whole bunch of new input plugins added, an output, a few serializers. With 1.11 in June, again, constant innovation, new things being added all the time by Influx staff and by community contributors. And this is a common pattern, right? We're always adding new things to this. So what that means is, as a consumer of Telegraf, depending on how much attention you pay to the releases, you probably don't know what's available and what you can start playing with. Also for us, we don't really know which plugins are being used either. So as much as we're adding all of this stuff, we're working with GitHub issues and feedback from people on our Slack and our forums, but we don't really have an idea about what people are doing with Telegraf. So I started searching on GitHub, and I looked for every telegraf.conf that I could find. There were 3,249. Unfortunately, the GitHub search API is actually rather restrictive. So I could only get 1,000 of them, because that was the max search results that I was able to download. But this is a time series conference, so we'll just call it a sample of 1,000. Now here's some of the things that I found. Of the output plugins, 72% of our sample size are using InfluxDB. And nothing else is really being used, like I can see across these files. Now we're going to take a look at some of the default settings. Now everyone seems to use the 10-second interval. It's probably not surprising because it is the default, and then various other things here. I didn't actually find any of the telegraf.confs on GitHub that were using anything lower than a second, which was actually a little surprising. With regards to the round interval, 90% of people are using this as true. With the jitter, 90% aren't bothering. And most people keep the host name as a tag value. Now, there's not a lot I can actually infer from this, but I'm going to assume that most people aren't running Telegraf in a container. Otherwise, I would see a higher number for the emit host name. Now, the number of output plugins being used, most people are just using one. That's just the InfluxDB one. Very few people are using multiples. With regards to inputs, very widespread here. Depending on your use case, you're using 1, 2, 3, 4, 5. The bottom one, I have no idea what that person is monitoring, but 56 inputs on a single config. Like, just run more than one Telegraf. Anyway. This isn't surprising either. Like, the most common plugins that are being used on the input side is all the system metrics, right? So CPU, memory, disk, network, etc. Very common use case for Telegraf. But that means there's a whole load of plugins out there that probably aren't being used that are very useful. So the first thing I'm going to talk about, and I'll go really fast over this because it has already been covered, but Telegraf can write your points to multiple outputs. Right? And if we're talking about migrating from Influx 1 to Influx 2, or you want to start testing Influx 2 just now, configuring both of those outputs and writing all of your points to both is just the best way to get started. Another feature that I don't really see being used very often, because I guess it is quite new, it came with 1.10, is that we actually have the ability to pull in a telegraf.conf from our remote location. You just specify --config, and you can use any HTTP or HTTPS URL, and it will download the config and run. So what I've started playing with recently is, the current trend within the operator world is GitOps. Everything should be committed to Git. When we use that pattern, we can then just reference directly to GitHub, GitLab, Bitbucket, any other service like that, and pull in our config direct. And it works really well. Of course, we have to be very careful when we do this. You don't want to commit secrets to these files. So just a little reminder that Telegraf actually supports environment variable substitution within the telegraf.conf as well. So that means you can do things like this. You can make the interval configurable at runtime. You can inject your token for InfluxDB2 and any other kind of configuration that you're going to need. So pretty useful trick. Now I want to talk about output resiliency. So this is a small config change you can make within your telegraf.conf that means that if your outputs ever go down, that you're not actually going to drop any of those metrics. Right? So we have some sort of buffering capabilities within Telegraf that goes, oh, output's not available, let's retry that again soon. The configuration option for this is the metric buffer limit. The thing to remember here is that it's per output. So if you are dual writing or even try writing or any more, if you set that to 10,000, it's going to be a multiple of that for every output that you've got. So this is what I kind of look at when I'm now starting to use my Telegraf within my applications, is that Telegraf is going out to all of my third-party software dependencies like Postgres, MySQL, anything like that, Kafka. It can fetch some things from my application depending on the runtime that's there. We have the ability to batch as well. So we can say, don't send 1 point at a time, batch them up into 1,000 or 10,000 and ship them. We also have the buffer that gives us the resiliency, and that goes to InfluxDB. We also have our application writing events to InfluxDB as well, so that's more a regular time series that still has to be captured. Now what happens when InfluxDB goes away is that the stuff on the Telegraf side has the buffer, so we're not going to lose anything, but all of the events that we're pushing from our application are now being lost. So ideally what you really want is for your application to use all of this really convenient stuff that Telegraf provides so that we get that same level of resiliency with the events that we're pushing from our application. So there are two plugins for this. We have the InfluxDB listener, and we have the HTTP listener. They both just create an HTTP endpoint that can be consumed, one with InfluxDB clients and one that takes just regular HTTP requests with different various formats. Now, the thing to note here that it's not a complete InfluxDB interface that's been provided by the listener. It's only going to satisfy the write path, which is great for most use cases that you're going to be instrumenting your application with, but you just should be aware of the small caveat. And it's super easy to configure. This was mentioned earlier as well. We just specify the port, that listener is going to run, we can point our application to it, and good things are going to happen. Now, there's a really cool side effect from this. Because we have that InfluxDB listener, is that if you are starting to play with InfluxDB2 and there isn't a client library available yet for your runtime of choice or programming language of choice, then you can use the V1 clients. And you can just run Telegraf as close to your application as possible with this plugin, and no code changes really have to happen. So that's pretty nifty. With regards to the HTTP listener, it supports any of the data formats that Telegraf supports. So you can send JSON, you can send just straight up values, CSV, or line protocol. And configuring that is just as simple. We just tell it some sort of port that we want to listen to, what kind of data format we're going to expect, and then our application can use any HTTP client that is available for your programming language and send those metrics across. Now, if you're using the JSON format, there is a little bit of extra configuration that's required. You have to tell it how to be able to parse that JSON as well. So here, we're just saying that anything within the JSON we want to consider a tag would be called goversion. We can add as many of the JSON keys there as we want, and they will all be added as tags. If we want to override or use one of the JSON values for the measurement or metric name, and we can specify that as well. There are a whole bunch of configuration options here. The slides are already on Speaker Deck, and there's a link at the end, but you can click the docs here, and that'll take you to the data input format configuration docs. And now I want to talk about something else that I've been working on with regards to Telegraf that's really focused on the container, using containers as a runtime for Telegraf, especially around a Kubernetes environment. So the plugins do come at a cost. The Telegraf binary isn't particularly small. When we wrap that up in a Docker image, it gets a little bit bigger because we have the operating system dependencies as well. And we really want to be able to get that smaller. So looking at the official Telegraf image on the Docker Hub, it's coming in at 254 megabytes. It's not massive, right? I'm not going to lose any sleep over that. But if I want to start adopting new patterns, especially around the container ecosystem like sidecars, then that's probably something that I want to optimize for. So using the bring your own Telegraf stuff that I'm talking about, I was able to get a Telegraf Docker image in under 16 meg. So that's a drastic improvement. If you've got a large infrastructure, you've got hundreds to thousands of Kubernetes workers in your cluster, then think of all the bytes that we're saving here. Now, what does it look like to build or bring your own Telegraf? Well, this is a Docker file. I'm hoping most of you have got some familiarity with this. The Docker setup uses on-build instructions, which is the Docker way of deferring any future build steps to the user build time. So we start off by saying from my raw code Telegraf BYO, this is our build layer, and that does everything for you. Right? There's no other steps there. Everything is done as an on-build deferred instruction. But once that build is complete, we're using the multi-layer stage to then pull in the artifacts from the build layer and give ourselves the Docker image. And that's all these instructions are doing. So we're saying copy from build, we grab the Telegraf configuration, and we grab the binary. That's it. So let me just click on these links. So this is the on-build Docker file. So it just starts from a small Golang Alpine-based image. We copy in some generative code that I need to handle the plugin changes. And then everything else in the on-build instructions is cloning the Git repository using whatever version of Telegraf you tell it to build. It then uses the code generation to generate the plugins all.go file. And that's not that important, but what's really cool here is that it's actually using your Telegraf config to work out which plugins are enabled and only enabling them. So that's why we're getting everything so small after the build. We then compile it, the binary is available, and then it falls back to the other layer. And if we take a look at an example here from GitHub as well, this is exactly what I showed you. The only thing that is also here in this repository is a Telegraf directory. Now this is the exact same Telegraf directory that you've already got that lives in /etc. And it can take the telegraf.conf, or it can use the .d format. And this is the exact same Telegraf config that hopefully you're using something like this. So this is automatically added to the build layer, parsed by Go, and the plugins all.go is generated, and you get a really small image. Hopefully this loads pretty fast. So there was another weird side effect here when I did this. When I first ran it, obviously I was very impressed that the binary was really small. So I patted myself on the back for that. But I started to notice the memory consumption of the binary was also a lot less. So I've had this running all day, 2 different Telegraf setups, one running normal official Telegraf image, one running the bring your own. And we can see here on the first graph, hopefully you can read that, I know it's quite dark, is that we have allocated bytes with the normal Telegraf at 5 million and 800,000 on the bring your own. So the amount of bytes being allocated there is drastically lower. We also have a common theme here. Now you can't see it at this kind of 5-minute resolution, but the blue line on the second graph is the gather time for each plugin, how long it takes for that plugin to go and fetch those metrics. Now the purple one, which is the bring your own, is rather consistent. There's no major spikes. And we see one spike here with the normal Telegraf. But if I actually zoom this out, we can see the blue line there. Now, I can't explain this, right? And I'm going to have to work with the Telegraf team on it, but removing the plugins does have a drastic effect on the gather time for each of the other plugins as well. So it's becoming a lot more performant. And there's just two more graphs here that are showing the heap and the number of objects on the heap. Again, much, much lower with the bringing it run. So I don't have a fancy explanation of why this is here, and I'm hoping someone on the Telegraf team understands this a bit more. But I just thought that was really cool that we've reduced the image size and improved the gather time for all of the plugins and drastically reduced the memory. And that's really important, again, because we're doing this for container-based workloads. This is a Docker image, or a container image. I'm going to be running many of these, especially in a Kubernetes. And I keep saying sidecar because it's a thing that I personally find rather interesting because I come from a Kubernetes kind of background. So let's go back to our architecture diagram. So we have our software dependencies being scraped by Telegraf, and we have our application right into Telegraf through one of the listeners. We have the batching and the buffering going to InfluxDB. But now with the bring your own, or this performance version of Telegraf, we actually can open up these patterns of, well, why don't we run as many Telegrafs as possible next to all of the applications that are being monitored, take advantage of all the buffers and metrics at each different edge location. Because this now means that we can be a lot more selective about the buffer metrics, buffer limits on each of these, depending on how valuable that data is to us. If we're monitoring a database, then it might be super important that we monitor slow query logs or any of the other event data there. So we're going to have a larger buffer size to handle a longer period of downtime for InfluxDB. And if it's something like the network that we're only passively monitoring and we don't have a great deal of knowledge of, then we can reduce that buffer thing, and that Telegraf is going to run along without using too much memory. So, lots of new patterns are starting to develop around us now. But if we're going to add all of these new Telegrafs to our system, then we actually need to understand how Telegraf is running too. It's very important that our Telegrafs are healthy and running because they're running at the edge in so many different locations. So Telegraf has had this for a long time now, since 1.2. Only 0.1% of the configs that I analyzed use the internal plugin. The internal plugin exposes all of the metrics from how Telegraf is performing. And of course, you need to keep an eye on the buffer size and metrics dropped. The buffer size, you want to make sure you're not getting too close to that limit, or you maybe have to do something. And if you start dropping metrics, then you probably want to alert on that so that you can go and fix it. So the internal plugin is a no-brainer. You can turn it on, and you get really good insights into how Telegraf is running. Another plugin that we're going to kind of look at quickly is the health output. Now, this is relatively new. It's only been added in 1.11. None of the configs I found on GitHub are using this whatsoever. Now let's talk about health checks for a second. I'm not sure how many of your application developers, but I know in my application developer in past days, this was my standard health check on any application that I wrote. I'm not actually testing anything about my application here, right? This is not a health check. Right? This is just an HTTP request that I'm assuming if it returns an OK, that my application might be working. But I've not tested any dependencies in my application. I don't know how long it's taken to respond, and nothing like that. Right? So this is bad. And this is what the health output can really help us solve in our infrastructure. So we define a service address. We just pick a port, and it's going to expose an HTTP endpoint for us that we can then use within our infrastructure to check if the application is healthy. We're going to analyze a single metric. So web metrics is the name of the metric here. And then I can add as many of these health compares as I want to look at different performance metrics within my application to actually determine if I feel that it's healthy or not. So for a web application, what I actually want to understand about the health of it is the response time less than 300 milliseconds? Now I can curl that endpoint as many times as I want, and if it ever fails a health check, I can either scale it up, or I can just kill it. Maybe it's a performance issue and spin up a new one. Now, so I'm talking about Kubernetes more, and we've got sidecars, we've got Telegrafs at the edge. You're probably getting to a stage where you may want to look at using Kafka, not just from a scale point or controlling the ingestion rate of the metrics to InfluxDB, but it allows you to consume that Kafka topic not just for InfluxDB, but for any other pipelining stuff that you may want to do with your metrics. So we're starting to evolve this architecture even more. We've got telegraphs everywhere. They're right into Kafka instead of InfluxDB. We now use Telegraf, which has a Kafka consumer, which I'll show you in a minute, that can consume that topic and then control the rate of writes to InfluxDB. What's also very cool is that we can use the Kafka consumer group stuff, and we can actually scale the ingestion of telegraphs by having them scale horizontally as well. So if we're writing millions of metrics or points per second, we can run many telegraphs to consume that topic and keep that in InfluxDB. So let's take a look at that just now. So what we have here is a Docker Compose project. This is all on GitHub as well. The links are at the end, so I'll explain as much as I can, but feel free to play with it later. What we have is chronograph running, InfluxDB 1, InfluxDB 2, Kafka, my amazing Python web application that's going to get VC funded any minute, and we have 2 Telegraf configurations. One of them is Telegraf Edge, so this is the one that's actually collecting the metrics, writing them to Kafka, and we have a Telegraf Consume, which is subscribing to the Kafka topic and putting all of the metrics into InfluxDB. And this is my Telegraf configuration. So I've set a large buffer metric. So I'm going to kill Kafka. We're going to then spin it back up, jump into InfluxDB, and we'll kind of look at the internal metrics that make that work. We have the InfluxDB listener and an HTTP listener running, so we can do a curl request and see that working too. I have a socket listener, which creates a Unix socket, really good for sidecar stuff as well, because you can share that in a volume of all the different containers in your pod. And we're using the health plugin to make sure that our Python application is healthy. When it's not healthy, it's going to be restarted by the Docker engine. And then I have my outputs. So we have the Kafka output here. There is no InfluxDB output on this configuration whatsoever. I've also added a Prometheus client, and I'll try and remember to curl that. I forgot when I was testing the demo myself. So. On the consumer side, much simpler. Connecting with the Kafka consumer plugin to the topic, writing it to InfluxDB 1 and InfluxDB 2. Nice and simple.
You would like to have some CPU monitoring on your Resiliency?
I think I have the plugin on the edge, right? No?
Yeah, on the edge.
Oh, no, I don't. Yeah, I'm sure there are many plugins I'd probably want to add to that for sure. This is just a very contrived demo. Now let's take a look at our InfluxDB. So this is chronograph with InfluxDB 1. We can jump into the Explorer, and we can see here that we have this we have this pattern of ups and then downs. This is actually the health check plugin. So we'll also look at this in InfluxDB 2. I only showed you InfluxDB 1 just because there's the dual write. So let's find web metrics and submit. And let's just do 5 minutes so it doesn't look as insane. Okay, so we can see there's definitely some patterns here. Now the reason is that my application isn't particularly great. In fact, if we take a look at this Python application, it's using the InfluxDB 1 SDK. It's connecting to Telegraf Edge. And it's sending a single measurement with the response time and then the total number of requests. Now, because I'm not a very good programmer, we also have a sleep that managed to skip by code review. And every time we send a new request to this Python application, it's sleeping for 1 second, and then 2 seconds, and then 3 seconds, and so forth. And if you remember from the Telegraf Edge configuration, we also have the health compares of the response time must be less than 5. Or the Telegraf health check is going to say it's failing. And that's what's causing this here. So every time we send a curl request, it gets to 5 seconds. Telegraf says this isn't healthy anymore. The Docker runtime kills it. Nice and simple. And we also have, so this is me inside of the container with Telegraf, and I've just got a few very quick scripts. So techo outputs the command and does it at the same time. So this is just an echo that pipes through to netcat and uses the socket listener to push metrics into Telegraf. We also have the tcurl that sends 2 HTTP requests with a JSON payload, which is also consumed by Telegraf and written to InfluxDB. So even if there aren't client libraries, there's always a very simple way to get metrics from any machine or software application as long as you've got an HTTP library or the ability to write to a file on disk. This is pretty cool. And one more was the Prometheus endpoint. Let's see if I can find it. Hprom. So close. User bin prom. So it's probably just not executable, but I'll just copy the command manually. So this is the Prometheus output. So it takes all of the metrics that are in Telegraf, exposes them on a Prometheus endpoint that Prometheus can consume. Obviously, InfluxDB on Kubernetes, we're working to make that as good as we can. But in the interim, you can have your Telegraf expose the Prometheus endpoint and take advantage of the horizontal pod autoscaler and a whole bunch of other stuff. So hopefully, in this kind of whirlwind tour of a few of the plugins that are available, you can understand that Telegraf, although the system plugins are all great and we can monitor machines, there's a whole load of other things that we can use this for. New patterns we can adopt to make sure that we have a resilient metric experience working with InfluxDB. So we have covered less than 10 plugins. There's a whole load of things out there. I would suggest going to GitHub, jump into the plugins directory, and just start playing with them. Right? There's a lot of really cool things there, things you can monitor, hopefully most of the things within your infrastructure. Thank you very much for your time. The deck is already on SpeakerDeck. The code is all on GitHub. Have a play with it. Feel free to reach out to me on Twitter if you want to talk about this anymore. But thank you very much for your time.
Any questions? There's one over there. Speakers being, microphones coming running down, going left, and it comes down the hallway, and it's...
When you explain about the buffer on Telegraf, when it cannot send metrics back to InfluxDB, I remember there is a setting to the amount of metrics that it can hold in the buffer. From experience, do you know what is the cardinality of how much memory? Is this about the memory or the number of metrics that it can hold before sending them?
I actually forgot to kill Kafka and show the redundancy there, but you can spin that up yourself and feel free to do it. But it's just a number of metrics, right? So there's no, I don't know if you can set a limit on how much memory that buffer can be. I'm sure Daniel or Greg can tell us that. No. So it's just a number of metrics. So if you say 10,000 and you've got 2 outputs, that'll hold 20,000 metrics in memory. If you don't have the memory there, bad things might happen, but if you do, it'll consume it. So it's nice and simple.
Cool. Thanks.
Any more?
You all just want pizza and beer now, right?